Hi everyone. Today I'm going to be talking about precipitation and cloud formation. So first of all, we're going to talk about how precipitation is formed. So one of the quotes that I really liked from the textbook says, "Most precipitation begins as snow crystals or other solid forms, but the warm air below the clouds often melts the ice so they fall as raindrops." So for precipitation to occur, millions of cloud droplets, and to put this in perspective, these cloud droplets are about 7 times smaller than a human hair. They must combine to make drops large enough to stay in water droplet form to reach the surface without evaporating. So from that statement, we can tell that water drop or cloud droplets are super tiny. So millions and millions of them must combine to make a water droplet that is big enough to reach the surface without evaporating. So two processes can explain how precipitation works. First is called the Bergeron process, and this is precipitation from cold clouds. So cloud droplets remain liquid at temperatures lower than -40 degrees, and this means that they're super cold. Super cold liquid becomes ice as soon as it hits objects. The second process that creates precipitation is the collision coalescence process, and this means that the precipitation comes from warm clouds, particularly in the tropics where there is salt water. So next we're going to talk about the difference between rain and snow. Rain, by definition, is drops of water that fall from a cloud and they have a diameter of at least 0.5 millimeters, which is 0.02 inches. Most originate in nimbostratus or cumulonimbus clouds. Raindrops rarely exceed 0.02 inches, and if they do, they don't survive because surface tension is exceeded by the frictional drag of the air. So, snow is precipitation in the form of ice crystals, otherwise known as snowflakes. The size, shape, and concentration of snowflakes depends on the temperature at which they form. So whenever there's low temperatures, that means there's low moisture content in the air, and that makes light and fluffy snow, kind of like whenever you go skiing, sorry. And then temperatures warmer than 23 degrees equals more moisture, and that means that there's larger clumps of heavier snow. So this is good snow for snowball fights, making snowmen, things like that. So now we're going to talk about the difference between sleet and hail. Sleet is the fall of small particles of ice that are clear to translucent. For sleet to be produced, a layer of air with temperatures above freezing must overlie a sub-freezing layer near the ground. Raindrops leave warmer air and encounter colder air below. They freeze and reach the ground as small pellets the size of raindrops that they originally were. So this means that whenever raindrops leave the warmer air, they come to the colder air below. They end up freezing on impact whenever they fall on an object. So hail, now we're going to talk about hail. This is the precipitation in the form of hard, rounded pellets or irregular lumps of ice. They're produced only in large cumulonimbus clouds with speeds up to 100 miles per hour and a large supply of supercooled water. So all of those three elements must be applied to produce hail. Okay, next we're going to talk about air mass. Air mass is defined as an immense body of air, usually 1,000 miles or more across and several kilometers thick. It is characterized by a similarity of temp and moisture at any given altitude. Air masses are classified according to their source region and nature of the surface in the source region. Polar and Arctic air masses are formed in high latitudes. Tropical air masses form in low latitudes, and continental air masses form over land, while maritime air masses form over water. So as you can tell, there's different air masses for different types of different temperatures of air. Excuse me. So now we're going to answer the question of why Oklahoma is so susceptible to tornadoes. Oklahoma is susceptible to tornadoes because it's located directly in Tornado Alley. Tornado Alley is another name for the Great Plains. The Great Plains let cold air from the Arctic flow south as warm and humid air come up from the Gulf of Mexico. This meeting of cold air and warm air results in the formation of supercell thunderstorms or tornadoes. So in other words, this meeting of cold air is typically a collision of cold air. So it's whenever they collide together. Now we're going to talk about airlifting. The lifting of air is important because air tends to resist vertical movement. So airlifting processes are imperative to keep air from staying aloft. Rising air means cooling to its dew point temp, and then saturation will happen. Then clouds will develop. The rising of air keeps the weather in motion. Now we'll talk about the airlifting processes, so how airlifting occurs. What first of the four processes, I'm only going to talk about two, but one of them is called orographic lifting. This happens whenever elevated terrain, such as mountains, act as barriers to the flow of air. As the air goes up a mountain slope, adiabatic cooling generates clouds and precipitation. By the time the air reaches the leeward side of the mountain, which is the side that doesn't face the winds, much of the moisture has been lost. Frontal wedging is another process. Frontal wedging is masses of cold and warm air colliding, and this produces a front. The cooler air acts as a barrier over which the warm air rises. This is associated with middle latitude cyclones.